And you'll get a note that says if you don't like that, you don't have to play. Uh, and I put together just a couple of thoughts of what got my brain going on this, and then I don't really have an agenda beyond that. If I make this a little more visible. After I finish this, then I'll stop sharing screen. We can see everybody. And this is what's happened to the price of solar since I started my career. In 1976, I was a graduate student in Bellingham helping build the Viking 3 automobile, and we looked at buying solar cells to build a solar-powered car, and we figured out that it was going to cost more than the cost of a new building for the technology department. And we kind of let that slide. Those costs are down 99.6% now. And we've learned more about solar cars and that it's better to put the solar system where it is behind me and plug the cars in periodically. Battery costs are down. This is Bloomberg data, and it sort of doesn't matter what the vertical axis is, because Goldman Sachs says that this trend is not over. And there's people on this call who know more than I do about what's likely to happen to battery costs. But Goldman Sachs has battery pack prices, and there's the batteries and the battery packs and the battery modules and the battery installations, slightly different things. But down in the $60 a kilowatt hour range, which is really pretty dramatic. I went to Lazard's most recent levelized cost of solar, and I just picked out 3 examples. This is a standalone battery in the California ISO, and they looked at the values it would bring of resource adequacy, compensation, energy arbitrage, frequency regulation, and reserves, and calculated a 23% internal rate of return. That should make things happen. And then they looked at another one here, wholesale in Texas. Now, there's no energy adequacy value there, but there's reserves, frequency regulation, and energy arbitrage. And there they calculated a 29% internal rate of return. And a C&I standalone in the PG&E service territory. This is like an office building or a university or something like that, with bill management, mostly controlling demand charges and shifting into time of use rates, and then local incentive payments and utility demand response compensation, and an internal rate of return of 26.4%. This is pretty dramatic stuff. So I came up with a few questions. Will battery costs continue to fall sharply? I posed that question to Tom Stars when he and I were presenting jointly about 6 or 7 years ago, and he said yes, and he was right. So I'm going to pose that question again. What is the effect of falling battery costs on? I listed 4 things that I think about quite a bit, but there's other things. And how does this affect rate design? What happens to time of use rates and demand charges when customers have cheap batteries? And I've got some thoughts on each of those, but I just wanted to kick that off. I'm going to stop sharing, open up the gallery, and I see that there's 13 of us here. I'm Jim Lazar. I'm retired from the Regulatory Assistance Project and a long career in utility regulation, renewable energy, and energy efficiency. And I'd appreciate it if I'm going to call on people, because I can keep track of it that way. Give the 20-second introduction of yourself. Dave Margolius.
Oh, yeah. You want a quick introduction?
Yeah. 20 seconds.
Yeah, I'm a business person who's focusing and climate activist who's focusing full time on trying to move the energy transition faster. And I love geeking out on the technology. So I'm on your list, reading it every night. And storage seems to be moving fast and disrupting everything. And I want to learn more about it.
Oh, Don.
Hi, Don Marsh. I lead a all-volunteer nonprofit organization that tries to interact with our utility commission and the largest utility in our state to try to see more incorporation of things like batteries, virtual power plants, solar, all the things. Thanks.
Paresh.
Hi, I'm Harish Kamath with EPRI. I've been working in energy storage for the last 25 years. In 2009, we made the projection that lithium ion prices would come down below $200 a kilowatt hour by 2020. A prediction that we were told would be irresponsible. Not only did it achieve that number, it achieved that number 2 years ahead of time. So we've been tracking those costs and watching that come down, and interested in hearing the perspectives around this group.
Kay Aiken. Hi, glad you're here.
Hi, Jim. Kay Aiken, company called Dynamic Grid. We're in a couple of different things. My volunteer work is with Gridwise Architecture Council, which many of you might know of, but it's the DOE-sponsored group to work on grid modernization. My day job is a DERMS provider on the circuit level, as well as soon to be, though delayed, storage manufacturing plant here in Maine.
Ted.
Yeah, Ted Pope with 2050 Partners, and mostly just interested to see what I can learn here. Our company does do a lot of codes and standards advisory work for utility clients, and we are doing testing on storage batteries, sized in the behind the meter category.
Claire.
Hi, Claire Broom. I'm a professor of public health and epidemiology, done cost effectiveness analysis. For the last 10 years, I've been representing 350 Bay Area at the California Public Utility Commission, trying to get distributed energy resources considered more seriously by the CPUC. We've had a string of recent decisions that have been very concerning in terms of trying to get to the grid of the future. So I appreciate what I'm learning from you all and hope we can make more progress toward incorporation of distribution grid assets.
Maria, your face is a little fuzzy, but maybe your voice will be wonderful.
Hi, Jim and everyone. I'm new to the Google group, and my interest is actually in utility rates and time of use and customer experience. I'm just newly entering into this arena.
Thanks. Chris King, nice to see you, sort of.
I'll turn on the video for a minute. Good to see you, Jim. Good to meet everybody. My day job is with Siemens, where I do strategic partnerships, strategic initiatives, work on regulations. Have a long history in the industry, as Jim well knows, in time of use rates. Did a pilot over 3 decades ago. Dynamic pricing, smart meters. And the business unit I'm in at Siemens is e-mobility, so it's EV charging infrastructure. And I am seeing, and Siemens is seeing, batteries just totally disrupting the entire energy ecosystem. And very excited to talk about this topic.
Great, thanks. Let's see, now things are moving around on my screen. Dan, Jamie, David, Douglas, and Ken, in that order.
Hi, good afternoon, everybody. My name's Jamie Leonard. I work for 2 organizations here in Detroit, Michigan Clean Cities and Next Energy. My background, lead electrification projects, and got exposed to the utility world through that. a little ways ago got added to the Google group, and just appreciate learning from all the great information out there. So figured I'd come listen in today.
Hi, Dave Millar with Wartsila, and I'm in our growth and development group. Wartsila, if you don't know, is Finnish manufacturer, and it does reciprocating engines for ships and power plants, and it's also the second or third largest battery storage integrator. So I look forward to the conversation.
I think I'm up next. I'm Douglas Jester. I'm managing partner of Five Lakes Energy. We're a consultancy based primarily in Michigan and Wisconsin, although everyone works from home, so some people are various places. And we do a lot of work in the regulatory process, integrated resource plans, things like that, and also have been long advocating, decarbonization. So we're now looking forward to the times when reliability issues are a drag on our ability to further decarbonize in the places where we work. A couple of years ago, we did an energy storage roadmap for the State of Michigan Energy Office, recommending some policy directions and a fair amount of modeling around that. And we've dealt with storage in decarbonization plan for a municipal utility in northern Michigan and a couple of other things. So it's something we've been interested in for a while. But Jim always frames things for prepared for big change, so I'm interested in what this is going to be.
Hi, Ken Colburn here. I did a lot of work at RAP while Jim and I were there together, not nearly long enough together. I'm I like to say retired energy geek, but it's not clear you can actually retire from being an energy geek. And so I'm co-chair of the Energy Working Group with of the Maine Climate Council. I'm on Efficiency Maine Trust Board, trying to move them forward more rapidly on a bunch of fronts, and mostly came to see a bunch of good old friends. Thanks.
And Ken, you and I have to stop meeting like this.
No,
We
I
were
know
on
you
a
guys stopped meeting
2 hours ago.
Any other way. We got somebody on the follow-up 703 phone number. Who's that?
Yes, good afternoon. This is Andrew Schlicht, a member of Maryland Commission staff.
Right. Oh, did I miss anybody? All right.
Hey, good afternoon. This is Dan Hurley. I'm also with the Maryland Commission staff, and I've been with the commission for almost 20 years. And I think, my group is really kind of responsible for reviewing and implementing and helping the utilities implement their programs to help meet the state's goals. And we do have a pretty large storage mandate from legislation passed a couple years ago.
All right. So, Harish and Kay and Chris and a couple others here are sort of inside the industry. I'm just going to flash my questions back up again. Sort of launch this as, our price is going to continue to fall sharply. And in particular, is there going to be a long-term storage technology that's successful? There's a whole heap of them out there. And that's probably the thing that people are most curious about, simply because long-term storage enables some retirements of some things that 4-hour storage doesn't. I'm going to shut up and listen to smart people now.
So as Jim knows, I'm often the first person to talk. Yes and no. Yes, prices will drop. I don't believe they're going to drop as fast as some Bloomberg and Lazar are saying. It's starting to flatten out the curve. And we have a problem with yes, cell costs are dropping because density is going up. Manufacturing scaling is helping somewhat. Electrochemical changes are happening, which are making differences. But as we move to larger and larger capacities in the storage business, the cost of system integration is not falling as quick as previously the chemistry level was moving, and I don't see that happening. G&A is not going to change appreciably. Cost of inverters aren't going to change appreciably. Containers are not going to change appreciably. The interconnection costs are not going to change much. So I think we're going to see this shallowing of the cost curve drop a lot quicker than people are thinking. 10 years ago, 8 years ago, totally, it was a very clear, steady drop down. That's gonna start leveling out.
Kay, do you have an estimate for what balance of system costs you just described are relative to the cells?
So if you look at the LCOS study, the performance-based study out of P&L, some of the best data. P&L is doing, I think, the best research on actual costs in the field because they're talking to developers and getting pricing directly from developers. They're not talking to Tesla, BYD, and Tesla and BYD have an argument to minimize what they're actually selling it for. They have an ulterior business motive to say, oh, it's coming down, way down, it's coming down, way down. Developers are people on the ground, people like myself. I'm doing storage projects. I'm delivering microgrids. And for instance, in end of 2022, the price for LFP at the 1 megawatt level, bear with me what the number was, but LFP was about $375 delivered. 60% of that was balance of system costs. And that's what's not dropping quickly enough. And I don't think it's going to drop that quickly because steel is still steel. It costs money. It costs money to pour concrete. It costs money to get an electrician to wire it up. So we're not going to see the big drops that if you just take the last 10 years of price and draw a straight line, you get a price of in like 31, they'll be paying you to take storage. Well, that's not going to happen.
Haresh or Chris, do you want to go take on Kay or tell me something else I don't know?
I'll jump in. I'm gonna largely agree with Kay actually. So prices have continued to fall. I actually thought that prices would have leveled out a little bit by now. And several years ago, I said, we would probably see it much flatter than it is right now by 2025. And I actually lost a bet against my CEO who said that the price would be, that it would hit a $70 price. And I said, no, I don't think it's going to hit a $70 price. It has hit that at the cell level,
At the cell level. Cell level, I think you're right.
Yeah. So the cell level, at the cell level, and again, I mean, that's maybe what was where I made my mistake was that, looking at the overall price, and again, remember, we're talking the dollar per kilowatt hour level. We're talking about, we're looking at it per energy. So a lot of the gains that have been made is because, manufacturing is a dollar per piece activity. And when you're looking at it the cell perspective, a lot of these folks have figured out how to put more energy into a cell of a certain size, even for lithium iron phosphate types of technologies. So on a cell basis, we're going to continue to see the price fall, not as sharply as it has, but somewhat. And just as Kay said, the system integration costs, though, there's still some major challenges there, especially G&A, permitting, all that stuff. It's not getting easier; it's getting harder. So that cost is not affected as much. I want to address the other question that you had there, Jim, about other long duration energy storage technologies. Long duration energy storage is the big buzzword of the day, and it feels very much like it was 20 years ago when we were talking about storage and before lithium ion came in and captured the entire market. You know, there's a lot of different perspectives here, even at EPRI. My perspective is I don't think those technologies will achieve commercialization before 2030. We don't have a lot of time before 2030, and commercialization is harder than a lot of people say. It took a lot longer even for lithium-ion batteries to make it to a point where we could call them commercial products, although people don't remember that now. It was about a 7-year period between 2009 and 2016 when it took a while for people to really get into that mode. I have colleagues who disagree with me and say that non-battery technologies will dominate long duration energy storage, 10 hours or longer, well before 2030. I guess we'll see. So, but those are non-battery technologies. I don't see any battery technology where the cost will rival that of lithium ion, and I don't see any battery technology having a profile that would make it cost effective, not just at 4 hours, but even at 24 hours. I think lithium ion will be the cheapest battery technology for 24 hours or below, at least until 2030.
Let me interrupt and ask who is the caller from Oregon on 541 number.
Hi there, this is Shannon Souza. I'm calling you from Coos Bay. I've been in renewable energy for about 21 years practicing. Started in rooftop, and now I do policy development in Washington and Oregon, working increasingly on utility scale, but also pertinent to this conversation, clean fuels generation, and with our eyes on our turbines in the Pacific Northwest.
Thanks. Did I get that right? Is Shannon?
You did, Shannon.
Okay.
Thanks for inviting me. Fred Hewitt invited me to this group last year, just based on a lot of the questions and conversations I have with him. So sorry for eavesdropping before introducing.
Chris, Kang, I want to put you on the spot a little bit here too.
That's fine. New technology. That's one thing I would like to highlight. Two new technologies that I've gotten personally familiar with and are rapidly approaching commercialization. In fact, they're building factories as we speak. One of them is using iron batteries for long duration storage, and probably everybody's heard of Form Energy. But if not, they're making a new technology, and their delivered cost is going to be about $50 a kilowatt hour. They're not going to get there in their first deliveries, of course, but they expect to be there well before 2030.
Yeah,
we'll have to see if they
$20 a kilowatt hour is.
Yeah, I mean the targets, continue to drop, right?
Yeah.
The problem, Chris, with iron air is the fact that its our round trip efficiency is so low. So that really, yes, they'll bring the price down because it's really cheap materials.
Yeah.
But their efficiency on the system, so we're going to have to triple the size of our renewable energy. We're already having problems meeting the amount of renewable energy we need on the system and interconnections and everything else. If we have to throw away, in effect, 60% of the power to handle an iron air battery, I don't think it's good for the system.
Yeah, I've said the same thing about hydrogen, and I'm curious what Chris has to say, and then we'll go to David.
Yeah, the other technology is a new, I guess it's a new anode cathode technology that improves efficiency by about 20% in lithium-ion batteries. And they're building a big factory in Arizona to deliver this. So 20% by itself is not a huge number, but you add some other technologies together over time, and then you see those drops that you saw with the solar cells. And Though I would certainly agree with you, Kay, on the other costs associated with it. And we see that in solar, right? The cells have dropped to nothing, but the other costs associated with installation are still, in fact, they're going up, right? It's harder to manage those.
David, Douglas, and then
Yeah, thank you. Yeah, so are these $70 per kilowatt cells, the same ones that are going to get 100% tariffs in 26? And I mean, how confident are you that you can achieve the same kind of cost reduction outside the manufacturing powerhouse of China?
Well, I could try to address that. I think, from our perspective, the cost manufacturing is not going to change that much because it's not a labor intensive process. It's not in fact, I mean, it's possible to produce cells, at least in principle, the same cost in the US as it is in China. It's just a question of, I mean, and we've demonstrated that, right? Lead acid is done exactly that way, right? Lead acid batteries continue to be manufactured in the US, continue to be competitive. And it's never had any kind of threat from overseas activity. The real question is whether manufacturers in the U.S. have the wherewithal to actually start that up for a business that they haven't been in before. That is a big question just in terms of manufacturing in general for everything. We've sent so much manufacturing overseas that I think that a lot of folks are underestimating the challenges with getting manufacturing restarted in the U.S., especially in terms of workforce development, and that's a big challenge.
Douglas.
I'd like, Jim, I'd like to add something talking about the tariffs. Is the tariffs are 100% on EVs. Those are fully manufactured EVs. The tariff on batteries are only 25%. So it's going from 4% to 25%. So all we are aware of exactly what we're talking about. For stationary storage, it's only 25%.
And the installed costs in China were down 43% last year. So 25% increase and a 43% decrease might add up to a nice round number. Douglas?
Yeah, thank you. So just a couple of points. In the modeling that we've been doing, I'm still not persuaded that long duration storage is all that important. There are some specific challenges that we need to address, but when we run the optimization models and allow both duration and power rate, or energy capacity and power rating to vary independently, even as we get to very high renewable percentages, we just don't see a large average duration. That doesn't mean there isn't room for some long duration in the portfolio of storage solutions, but it's not like to balance the grid, we need large amounts of long duration storage.
That's an important point. I did some sort of a one-day modeling exercise several years ago of taking South Texas wind, which has one load shape, and West Texas wind, which has another load shape, and solar, and put them together. It just, when I sort of optimized the mix of those, it was very close to 1/3 each. I wound up with a storage need for only about 4% of the day's load. Now that's one day. And it wasn't a hot day or a cold day. The modeling gets a lot more complicated when you're actually responsible for keeping the lights on.
Right.
Yeah, I think asset diversity is the key, and I think that's what you guys are talking about.
Yeah.
It's about mixing solar with wind, with hydro, with location. All of those things come into play and level the curve.
Yeah, I mean, there was a day a couple of weeks ago when California prices were minus, I was just a time that I clicked on grid.io. California prices were minus 17 and Texas prices were 385. And I said, there's a place for a little interconnection here somewhere. Don?
Yeah. The other thing that comes into this picture is, of course, load flexibility, and we're all aware of, the potential for either managed charging or VITA, whatever, with EVs. But we've been doing a lot of work on modeling what industrial decarbonization looks like in the Midwest. And, if we achieve industrial decarbonization, there's going to be a very large amount of electricity going into industrial heat. And heat can be stored relatively cheaply. The costs of doing so are primarily in integration rather than in the materials. I'm not talking about, using the heat to make electricity now. I'm just talking about make heat, store it for when it's needed. But we get very large numbers for, how much electricity would be used to make heat, and then, how much of that could be managed through heat storage. So
yeah, when I wrote Teaching Dr. Fly, I thought that ice storage air conditioning would be the big product of this decade. And that hasn't happened, in part because battery costs have dropped so much. And is heat storage going to be a better product than ice storage? I don't know.
Well, Ice Bear failed because there were no rate plans to make it cost effective.
No, Ice Bear failed because they didn't know how to run a company. I worked.
Well, that's true.
Touche.
That's it. Anytime we've got a $12 a kW demand charge, we've got a business model. I mean, that's what CalMac has said, and Ice Bear was playing in the same demand charge moderation business market, which was when I showed the graphic from Lazar, that's a big part of the value in the behind the meter installation is bill management. Don?
Yeah, so on the long duration storage question, first of all, I'll just say my resume is not equal to most of the people on this call, so to take my comments for what they're worth. But I did attend a presentation by Form Energy to the Northwest Power and Conservation Council, and going into that, I have to say I was kind of skeptical about the long duration thing. I didn't know exactly how it fit in, and besides, the batteries are, as you say, the round trip efficiency isn't that good, and it's not particularly fast to charge or to discharge. They're heavy, take a lot of land. So I thought there was, the cheap price is great and the materials are great, but I thought there was a lot of factors on the other side. But what I learned in that presentation, which I thought was new to me anyway, was when they were talking long duration, they were really looking at really long duration, like seasonal storage. I had no idea that was in play, but they did an 8,600 hour round the clock year-long simulation, and they showed that the net flow of the batteries changed throughout the seasons, and that this was actually really interesting in the Northwest where we are, because we do have sort of an abundance of hydro resource in the spring as snow is melting, and then it really trails off, especially in a low hydro year, late summer, early fall. We're starting to hurt in that area, and if we can time shift some of that spring flow to fall, the late summer, fall, maybe some winter peaks, then I seem to actually address a need. So they weren't saying it replaces everything. In fact, they were showing that lithium ion, is still good for the short duration peaks and stuff. But this was more of a seasonal play, and by their calculations, they had like a 6% reduction in cost throughout the year. So that's what I heard. You could tell me.
The low round trip efficiency of iron reminds me of a project Fred worked on for quite a while, which was a compressed air storage, which had sort of the same limitation. And I'm sorry Adam Dorr didn't join us. He made some comments on my notice of the meeting, but he's a, big believer that there's going to be lots of curtailed wind and solar available to store or make hydrogen or do something low value with, and when you look at how much solar California is curtailing just in the last week, it's, it's May, it's not hot yet. It's the time of year that curtailments are highest. But there's clearly a lot there. I wrote a short piece. I'm gonna pop the link into the chat that I posted on Energy Central about how the big batteries in electric vehicles will accelerate grid defection of solar customers in warm, sunny places. No, okay, not in Maine anytime soon, but in Brisbane and Honolulu and San Diego and in the Caribbean, places, in particular places where the electricity comes from petroleum island systems, tropical island systems, I think is where it's going to happen the most. And, pragmatically, if you've got a solar system that produces the number of kilowatt hours in a week that you use in a week, the amount of storage you need to carry you across the low points of that week is not all that high. And as we start seeing electricity prices in San Diego that, are in the 50-cent range and in the Central Valley in the 40-cent range, I'm curious of other people's thought about how much load defection and how much actual grid defection we'll see. But I'll come back to Dave and then Don.
Yeah, I've got just one more thing while I'm here, while I have my hand. Just looking at your graph on the reduction in battery prices, I feel like a lot of that was still basically sort of same chemistry. There was, we're learning a lot about manufacturing and stuff during that time. I feel like the forces on battery prices now seem like they're changing because of just mass adoption and a lot of competition for between companies and between different chemistries. I understand the connection costs and all of that, but also we're going to start seeing batteries in a lot of places where they weren't before, behind the meter.
My brother just bought a used Chevy Bolt from Hertz for $17,000. It got a 64 kilowatt hour battery plus 4 wheels and a decent stereo thrown in. So that's a $300 kilowatt hour battery on wheels.
Yeah.
And so that was the, what kind of seeing figures like that was made me start thinking that people are going to start using these 60 kilowatt hour batteries in their cars for load defection and outright grid defection. I think of my friends in Hawaii who have cut the cord with a 20 kilowatt hour battery, and if they gain access to their car battery, and thousands and thousands of people have them, are they in a position to say, "Oh, the power company"? Dave, okay.
Yeah, so just on the costs and these falling cell costs, for that to make its way into the grid and have impact, like you need productization to get the rest of the balance of system costs down. So that's kind of my question for this group is, what are the biggest productization opportunities for this LFP stuff for the grid, where you can have a factory that's cranking out a use case of form factor that can just be dropped in, and they can really get those balance of system costs down and take advantage of the cell costs so that it really becomes more disruptive than maybe we think over the next couple of years on the grid. Do people see that productization happening in terms of grid storage?
So
I could talk a little bit about that for just in a general sense, but I've been looking at productization of, local grid. And there's the one that you put behind the meter, and there's the one that you put in the neighborhood. And you need the one in the neighborhood has certain appeal, but the one behind the meter is really strong for reliability. So it depends on how badly people want to have 100% availability on power. I think you got to look at all three parts of the triangle: the environment, the reliability, and the cost. And I think people are willing to pay a little bit more in capital costs to go on to their home because they're more apt to recoup that cost when they sell the house. But it's finding a product, though, is important. Right now, I was a little late because I'm putting 3 power walls on my house right now. I do think long duration, where that's defined as greater than 4 hours, has value. But I'm surprised that the studies that people have done show long duration is a very valuable thing.
So I'll talk about 2 things, and I'll build off of what Fred said just now. So we got to define what long duration storage is. So form is defining long duration storage as 10 days. And that's because of their way their technology charges and discharges. I think the majority of the value is going to be this 10 to 24 hour. And I do this from experience, and that's based upon microgrids needing to shift the solar curve to the evening and night time. So that's where we're going to get the main buck. I think you talked about it, Doug. That's where the big value is going to be. It's not going to be the 2-hour and 4-hour batteries, because that's really frequency response. That's peak demand stuff. Yeah. It's going to be moving solar from the day to the night. And that's where we're going to see a big amount of batteries increasing. And then
well, the 2 to 4 hour batteries are going to displace peakers.
I'm sorry, what?
The 2 to 4 hour batteries are displacing simple cycle peakers.
Totally.
And that's a good thing. And 10-hour to 24-hour batteries are going to displace combined cycle or baseload generation with 3-cent solar and 3-cent wind. And that's a good thing. Aren't those 2 different applications, and aren't they both important things to decarbonization?
I totally agree. I believe so. Yes, totally. And that actually talks about the question from Dave about commercialization. What are the things that are challenging us on commercialization? And I think that is they often say in the microgrid world, when you've seen one microgrid, you've seen one microgrid. And that's kind of the way batteries work. Grid scale is a little more, it's just tinker toys. I need a 4-hour, 100 megawatt battery, or i.e. 400 megawatt hour battery. I prefer that nomenclature. Give me the energy, how much energy we had there. That's a tinker toy. Where we get into things is where Fred was talking about, where we have behind the meter, which is very, very load curve dependent, and what solar you're putting on, and community level, which is and building level, which larger building, that is commercial building, is very load curve dependent. And those are going to be custom designed. And that's where we're having problems. Is you go to Tesla and you buy a mega pack, it's 3 megawatt hours. With a discharge rate, 4-hour discharge. You want anything else? That's what you get. You get a black Ford. That's all you have. Black Model T.
And building a microgrid for a multi, consumer application, that's really important. But Chris has posted some stuff recently, and I'm thinking about myself. I live in Honolulu. My house is an average house that uses 15 kilowatt hours a day. And I've got a Kia Niro and a Ford Lightning parked there. So I've got 200 kilowatt hours of storage. I've got 10 days worth of storage for the house and my 2 cars. And both the Kia and the Ford have existing stuff available to integrate them to the house. And the Kia is a small inverter that just plugs into the J1772 socket, and you can run your fridge and freezer and some lights on in an outage. And the Lightning has a more expensive whole house support system available to it. But at the individual consumer level, are we going to start seeing people say, "Do I need a power company?"
I hope not. Because that's going to be the detriment to our system, because we all can't be islands. Albeit I know Hawaii can be, but
it's not an island, okay. I start thinking of electricity becoming more like toilet paper. Okay. That, all through the COVID crisis, we never ran out of toilet paper. Whereas the factories making it, and the warehouses near the factories, and the warehouses in the community, and the storage in the store, and the storage on my shelf. And, we went through a pretty serious supply disruption that didn't actually affect me at all. And if we are getting to where we can make electricity when it's cheap to make it, either transmit it when there's capacity available to transmit it, store some of it at the point of production like we do toilet paper, store some of it at the point of consumption like we do toilet paper. Do we dramatically reduce the role of the utility in the case of customers in warm, sunny places? But for the rest of us who live in places like Olympia, where I live, in Maine, where Kay lives, do we wind up with a much higher capacity factor on a transmission system with lots of local storage, enabling us to make power when it's cheap to make it with whatever technology works, and use it when we need to use it?
well, I think that's totally right. That's Lorenzo Christoph's argument. Is we need to build local community efforts. Fred's trying to do the same thing in his area, is build local community efforts where we're really just concentrating on the T&D interface, and the utility becomes residual supply rather than main supply. And that should be the model. But if we have grid defection, if we actually have people cutting the cord, that will hurt the overall network effects of the grid. We need network effects.
If the utility charges $50 a month, then people will defect. If the utility charges $5 a month for a connection, or $15 a month for the connection, people will stay connected. This comes into the pricing world that I've lived in. Is
right.
Nevada Energy is seeking a $45 fixed fee. Fred is facing
I live in that world. And right now I'm looking down the road, probably $25 from SCE. And SCE's made it clear that, well, that's the start. They're going to be going up. And they're going to be going up to the point that I'm going to have pain. And I need an alternative so that it caps. I need to know some idea how high can Edison go before I go.
Let's get to David and Shannon, and then I will actually want to bring in the folks that are the other folks in the industry.
I got one more thing. To add just about loss of load expectation and large storage. And that is that I did a lot of studies on that back in 2021 with the Gregory County Pump Storage Project. And we ran an awful lot of LOLE on what we need in MISO and SPP, because it was in both of those. And it was somewhere, like where Kay says, right in the 10 to 24 hour basis of storage that we needed, the pump storage. You could argue something like 24 to 30 hours, but that was pretty esoteric.
David and then Shannon.
Thanks. I wanted to go back to something that Kay said just a little bit ago about, and I agree with your framing of 2 hours duration to 6-8 hours is frequency response, peaking capacity, and then we talked about form, and that's like kind of in the same world as green hydrogen, something that's supposed to deal with a Duke and Flauta situation, winter reliability event, right? But this 10 to 24 hour storage technology, I think we know that's not going to be lithium ion. And so that world is just such a weird, there's just so many weird ideas, like the giant balloons and the weights that you lift up in elevators. I mean, what do you think is the technology there? So that I haven't been able to sort of figure out.
Shannon and Chris, unless Shannon, if you're actually driving, I'd rather you focus on that.
Safety moment.
Go ahead, Chris.
But
yeah, this actually partly answers the last question, but Jim, you talked about EVs. There's a massive amount of storage available in EVs. It's not accessible. It's in multiples of the grid connected storage. But we need some technology there. We need some regulation there. What we need is low cost bidirectional charging. And we need to get there by putting inverters in the vehicles, which the vehicle manufacturers are still figuring out exactly how they want to approach this. But to get really mass market where you don't need another inverter in your house that's going to cost you $2,000, $3,000, $5,000, that really brings the cost down of doing that. And most of the automakers have said they're going to do two-way vehicle to home stuff no later than their 2026 models.
Yeah.
So the industry is moving that way. We're not there yet. We've got work to do, but it's going to be a massive disruption 3 to 5 years out.
Yeah, I mean, I've got a 3,000 watt inverter in one of my vehicles. It's, a $500 investment. It allows me to, run everything I need to run in the house during an outage. That's in a petrol vehicle. This is not a technological challenge. It's not an economic challenge. It's in part an institutional challenge, but I think it's mostly a chicken and egg problem. Nobody's doing it, so nobody knows about it, so nobody wants it, and nobody's buying it, so nobody's making it.
Well, people want
I'll give you another chance here.
Hi there. I'm not driving. I pulled over. Can you hear me now?
Yep.
Okay, cool. A couple of things. I wanted to talk about the long duration storage, and I think that just as much as if you've seen one microgrid, you need to look at the community level and distribution. As I said, I'm talking to you from the Pacific Northwest. I spent the last 30 years raising my children in a community that is used to 1 day to 5 day power outages, because we are at the very end of a 100-year-old piece of transmission infrastructure. We have low population center, low priority for repowering. So different communities, a lot of that has been lost in the past in terms of aggregating, but now that there's such a tremendous focus on equity, I have been using my engineering and energy background to focus on that aspect of the equity play, which is making sure that our communities at the end of the line have a lot more reliability. And I wanted to so talking with Power Planning Council up in the Pacific Northwest, what Forum would like to see in terms of 10 days notwithstanding, they're looking at somewhere between 28 to 100 hours in their modeling efforts to try and establish that level of grid resilience, but more of that, that's still driven by the reliability and the more direct correlation that climate has on our hydro-based system here. Which brings me to hydrogen. And the thing to remember about hydrogen, once we get over 12 hours, we're seeing that it's kind of marketable. That's in terms of long duration storage, but you need not limit that to the power sector. When we can co-locate with multiple other uses, long duration transportation, where hydrogen is showing up, and in the clean tech manufacturing space, those very EV batteries, those high performance EV batteries that are being manufactured up in Washington State, they need, guess what, hydrogen. So it's an interesting challenge that we have to really try and model and project, where is that going to show up? Where does it make sense? Yes, it's a low efficiency, full turn cycle, but when we have existing assets in the terms of natural gas plants, and if there is an opportunity for purpose-built renewables, opportunistic power purchases when the power is low, and then you bring in biogasification of biomass in the Pacific Northwest. I'd say it's a formidable and very large-scale wild card at this point.
Well, I thought I should keep this to an hour. I called it kind of on a spur of the moment, where I was saying, there's a bunch of smart people out here. Rather than have 300 emails bouncing back and forth, why don't I invite people to what I call a y'all come meeting? I appreciate the fact that we got 2 dozen people here on that kind of notice. One question: is this a good idea? Should the Electricity Brain Trust do this once in a while on a topic? And obviously, any of us can pick a topic and call a meeting. It doesn't have to be myself or Ahmed or Mark LaBelle, the people who moderate the Brain Trust.
I think it's a great idea. It's nice to have actual conversation.
Yeah. I'd like to put faces to. I only see email addresses. A lot of you I've never seen.
Yeah, it's easier to follow than 100 emails in a row. So.
Never seeing me might not be such a bad thing, but that's okay.
I'd like to interject something. When we were talking about bidirectional charging for electric vehicles, it's going to be a lot more effective if we have bidirectional electricity rate designs, which I've been promoting for a decade. And as far as I know, it only exists in Fort Collins. If you really want bidirectional charging to make money for the EV owner, then you need bidirectional rate designs. Am I wrong, or someone else thinks?
Oh, there's quite a few places now that have bidirectional rate design. Hawaii's time of use program is a bidirectional rate, and I'm seeing plenty of utilities looking to collect their fixed charges, if their distribution costs in fixed charges, and then have a bidirectional power supply rate, primarily in areas that are restructured where the power company itself is not in the electricity supply business. But in Hawaii, it's bidirectional at 20, 40, 60 cents a kilowatt hour off peak, mid peak, on peak, and that's a lot more appealing to folks. There's a customer charge to cover the cost of connection to the grid. There's a grid access charge to cover the site-specific capacity investment on the grid, and then all of the primary distribution, transmission, and generation is in the bidirectional time of use rate. All right. Well, I'm going to say this meeting is over. I'm not going to actually stop the recording until people stop talking. So if people want to keep going, that's fine.
Thank you for organizing this, Jim.
Thanks for coming, Chris.
Yeah, thanks, Jim.
Thank you for your time, everyone.
Thank you.
Thanks.
Thank you, everybody.
Thanks so much, all.
Jim.